Swift, functions can have multiple return values. The syntax for such scenarios is shown here. We have the familiar keyword function followed by the function name, and a set of parentheses which would include the names of the input parameters, the arrow to indicate that the function is actually have some return values. Then we have another set of parentheses in which we'll list the name of the output parameters that we are returning. We follow the same format as in the case of the input parameters. First, the name of the parameter, followed by colon, and then followed by the type of that parameter. Each of these are separated from each other by commas. This structure is the structure of a tuple. Then we have the body of the function, which includes any code which is necessary. And because we are actually returning this tuple, we have to use the keyword return followed by a tuple which includes the values that we are going to return. The number of elements of this tuple must be equal to the number of elements of this tuple, and also the data types of the individual elements of this tuple should be the same as the data types that are listed up here. Although we do not mention the names of the tuple elements from up here in this arrangement, we could actually do that. So instead of just saying x0, which is generated within the body of this, which is the value of the parameter, we could say output name 0 colon followed by x0, and we could do the same with the other tuple elements. So in this case that we are not mentioning these names, it is understood that x0 is going to be the value of output name 0, and xn is the value of output name n. The function call for such scenarios is something like this, where we have the function name followed by the list of the input parameters. This function call will return a tuple with this format, and here we are assigning that to this variable called return tuple. Then, like any other tuple, we can extract the elements of this tuple and use it in the remaining parts of the code by either using indexing or using the names of the elements of the tuple, namely output name 0 to output name n. Here is an example. We have a function with name sum function. We have two input parameters, in1, in2. One is of type double, the other one is of type int. Then we have a tuple which is returned by this function. The names of the elements of this tuple are out0 and out1. The types of these are double and int. Within we have some local variables. Then we have the body of the code, and the body of the code generates two values, m0 and m1, and we are returning these two values by placing them within this tuple. So as a result of running this function, we get this tuple containing two values back. Notice, as I mentioned before, that the tuple elements are not named here, but if we wish to do so, we can do that. Now, when we are calling something like this, we can follow an example like this. Here we have a variable called return tuple, which is assigned the return value of this function call. Then we can access the individual elements of this tuple by either using the element names or by using indexing. In this first example here, we are using the index name for the first element of our tuple, and in the second case we are returning the second element of our tuple, which is m1, by using indexing using .1. In Swift, it is possible for a function to have a return type which is an optional tuple. Here is an example showing such a scenario. The syntax that we use is the same as before. The only difference is that we place a question mark in front of the parentheses including the elements of our output tuple. So this structure is showing that this function is going to return an optional tuple because we are using this question mark. So we have the body of the function, which could include any code. Then here if we're saying that if a condition is true, we return nil, otherwise we return a tuple. One thing to notice here is this question mark is put in front of the entire tuple. That means that when we talk about nil, we are talking about a tuple containing no values at all. That would be different to having an optional value for individual elements of this tuple. Then the function call is again the same as before. What happens here, we call the function, and this function will return an optional tuple which is assigned to this variable. Now let's have a look at an example where instead of having the entire tuple to be of an optional type, we only have a single element of this tuple which is of an optional type. So here we have the first element or the first output parameter which is of an optional type, and within the body of the code we generate nil for this single element, not the entire tuple, if a certain condition is true, and our return statement includes a tuple whose first element is nil if this condition is true. And if that condition is not true, we actually assign a non-nil value to the first element. So again, notice the difference that the nil here is inserted only for one element of the tuple, whereas in the previous case, nil was generated for the entire tuple. The function call is again done in a similar fashion. Let's have a look at some examples for the cases where the return type is a tuple including some optionals. The first case here is where the entire return tuple is an optional. So based on the value of the function input parameter, we decide whether we return a nil for the entire tuple or we return a non-nil tuple. So when we call the function, if we set the input parameter of the function to 0, the if statement here is activated. As a result, a nil is returned by this function, which is assigned to return tuple. If, on the other hand, we set in1 to be equal to 1, the if condition here is not satisfied, and we return this tuple including two values, 20 and 10, which is non-nil. Now here is a case where we only have an optional element within the tuple. This is the case where the entire tuple is not an optional. Then again, depending on the value of the input parameter, we decide whether we return a tuple whose first element, not the entire thing, whose first element is nil. And if the condition is not satisfied, then we return a full tuple where the first element is non-nil. So again, if input 1 is equal to 0, the if condition here is satisfied and we return this tuple. And if in1 is equal to 1, then the second tuple containing elements 20 and 10 will be returned. So far in the discussion of Swift functions, we have mentioned that input parameters can have their names and their data types mentioned in the list of the function input parameters. In addition to parameter names, we could use argument labels, and the argument labels are used to make function calls more sentence-like. The syntax for using argument labels is something like this, where we have the familiar list of input parameter names and their data types, but in addition, before the name of each input parameter, we insert a label. In this case, I'm calling them argument label 1 and argument label 2 for this particular example. So it is important to notice that we have the argument labels as well as the parameter names. Then the rest of the syntax is the familiar syntax that we've seen many times before. When we are calling a function which has argument labels, we have to use the argument labels in the function call. If the argument labels are present, we are not allowed to use the parameter names. So here we can see an example where this function is called, and then instead of using in1 and in2 as we would use as in the previous cases, we are using the argument labels, and then following that we have the colon and the parameter value. One important point to mention here is that although the parameter names, when we are defining a function, have to be unique, we can't repeat them, the argument labels can be reused within the list. But it is perhaps not a very good idea to do that, but as far as Swift is concerned, that is not an illegal thing to do. Let's have a look at some examples for argument labels. Here we have a function which has two input parameters, in1, in2. They're both of type string. Then for the first parameter, we're using a label called walk from, and the second label for the second parameter is to. Now, what this function does is very simple. It just prints this sentence, which says I walk from whatever the value of in1 is, and to whatever value of in2 is. So notice here that within the body of the code, we do not use the argument labels. The argument labels are only used in function call. The body of the code uses the names of the input parameters. So when we call this function, we call it like this, the function name, and within parentheses we use the argument labels because we have argument labels. If we did not have argument labels, we would use the parameter names. Now with the argument labels, we just mention those followed by colon, and then this is the input value, home and work. So as a result of this, the printout would read, I walk from home to work. Now, one very important point is, if the argument labels are not included in the function definition, Swift treats the parameter names as argument labels. So it is correct to say that a function is always called with argument labels. If the argument labels are mentioned, we use those. If not, we use the parameter names as argument labels, and then we call the function. Here's an example when we have only one argument label. For the first parameter, we are not using an argument label, but when we're calling the function, we use in1 as the argument label for the first input parameter, but we use to, which is that argument label which is specifically provided for the second parameter. So again, I repeat, if the argument labels are present, we have to use them. If they're not present, Swift will treat the parameter name as being an argument label, and then we use the parameter name in our function call as if that was an argument label. There are times that we may wish to avoid using an argument label for a particular input parameter of a function. In such cases, we use an underscore as the argument label for that input parameter at the time of function definition. An example of such a case is shown here when I'm using an underscore as the argument label for the first input parameter of this function. So at the time of function call, I avoid using an argument label for the first input that I'm passing to this function. But I'm still using the argument label as usual for the second input parameter, which has a normal argument label. If we wish to use default values for some of the input parameters of a function, we can do so by mentioning those default values at the time of function definition. Here's an example where we are using a default value, school, for the second input parameter to this function. The setting of the default is done within the list of input parameters, and we use an assignment operator to assign this default value to our input parameter. At the time of function call, if we do not wish to use the default value, we pass the values to the function as we usually do, and we ignore the fact that a particular input parameter has a default value. So the first example here is when we do not wish to use the default value school for our second input parameter, and I'm just passing the value work for that parameter. On the other hand, if we wish to use the default value, we don't mention any information about our second input parameter at the time of function call. Here I'm calling the function as if it only has a single input parameter, and I'm ignoring the second input parameter completely. In such a case, Swift understands that I'm wishing to use the default value of the second input parameter. Default parameter assignment can be done for any of the input parameters of the function in any order, but for the sake of clarity, it is better to place all the input parameters with default values at the end of our input parameter list. An input parameter which is declared as variadic can accept 0 or more values at function call. The type of all these values is the same, and it's the same as the type of our variadic parameter, which is defined at the time of the function definition. To indicate that an input parameter is a variadic input parameter, we need to append 3 dots to the name of the parameter data type at the time of function definition. Each function cannot have more than one variadic parameter. So 0 or 1 variadic parameter is allowed for a given function. An example of the usage of variadic parameters is shown here, where our second parameter is variadic. I'm showing that by the 3 dots I've placed after the data type of our input parameter. Within the body of the function, a variadic parameter is treated exactly like an array. At the time of the function call, if we wish to pass 1 or more values for a variadic parameter, we list those values, separating them by a comma. If we do not wish to pass any values for our variadic parameter, we don't mention any information about that parameter. In this particular example, I'm just providing the information for the first input parameter as if this function has only one input parameter, and there is no mention of the second input parameter. Ordinarily, the input parameters which are passed to a function cannot be changed by the function, and the function can only read them. The function is only capable of modifying its own local parameters. However, if it is desired to change the value of the input parameters, we can place the keyword in/out before the name of the data type of our input parameter. And this has to be done at the time of function definition. Please note that in-out cannot be applied to variadic input parameters. And also note at the function call, the pass parameters have to be variables. They cannot be constants or literals. That is for the obvious reasons that constants and literals cannot be changed anyway. At function call, to indicate that we are passing a value for in-out parameter, we place an ampersand before the value that we are passing to the function to indicate that the function can change it. Here's an example where the second parameter is defined as an in-out parameter. The second parameter is now changed within the body of the function because it is in-out. The example of function call is shown here, where we're using two input values x and y, which are set to 5 and 10 respectively, and then we call the function and we use an ampersand before the value that we are passing for the second input parameter, which is an in-out parameter. Then we are printing the values of x and y after the function call, and the result is shown here where x is equal to 5 and y is equal to 15. So note that as a result of the function call, the value of y, which used to be 10, is now equal to 15. So the function call has resulted in changing the value of y from what it used to be before the function call. One final point about in-out parameters is that in-out parameters are not part of the function return values. As a matter of fact, we can have a function with no return values but some in-out input parameters. That is actually the case with the example that I'm showing here. With this, we reach to the end of the second part of our tutorial on Swift's functions.